I'm Eric R. Christoph of HoverAndSmile. Welcome to the second video in our RC Power series focusing on electronic speed controls, ESCs for short. Our first segment covered LiPo batteries. Our later segments will cover more components of your RC circuit. For more information on the series, please check the URL below. This focuses directly on electronic speed controls. We'll be covering at a high level what an ESC does, what kinds there are, what ratings that you should look out for, and also how the general connections work. We won't be going into too low a level as how to program an ESC. We may hit some of those points and topics on different ways to program them, but this will be more from a power standpoint of your circuit, knowing which ESC will work and which ones won't. So let's take a look at our circuit diagram and see how these things connect. Electronic speed controls, ESCs for short, bridge the gap between your battery, motor, and receiver. The ESC takes input from your receiver, while often supplying power to your receiver, to drive your motor with power supplied from the battery. So ESCs have three connection points: two wires for your battery, a set of wires for your motor, and a set of wires for your receiver. There are two primary types of ESCs, and they must match the type of motor you're using. It's quite simple. Brushed motors go hand in hand with brushed speed controls, and the same goes for brushless. Brushless motors must match with a brushless speed control. Big difference here is related to the motor. We're not going to go into too deep a detail, but just know that you can't mix and match. You have to keep brushed to brushed and brushless to brushless. Your brushed ESCs are easy to identify because there's only two wires to go to the motor, and since brushed motors only take two wires in. Likewise, brushless ESCs have three wires going to the motor, and the brushless motor has three wires to connect to the ESC. As long as you keep your pairs the same, brushed motor and brushed ESC, brushless motor and brushless ESC, you'll be fine. Doesn't matter what battery or receiver you use. Now, as far as the power for your receiver and servos, you could have a separate battery pack that powers that receiver and servos, and your main battery pack to power your motor. But ESCs have a nifty little component embedded inside called a BEC, which stands for Battery Eliminator Circuit. The BEC is basically a voltage regulator. It takes a high voltage in and lets a low voltage out. Why do we need to do that? Well, your receivers typically only allow 3 to 9 volts of power in them. Any more than that, they're going to fry. If I've got a 3-cell battery, I'm already at 11 to 12 volts. I plug that directly into my receiver, I'm going to let the blue smoke out. So the BEC handles that by regulating the voltage. Your ESC still allows the full power of your battery to go through to your motor, but the BEC regulates that down to a safe voltage for your receiver and servos. You'll see if your ESC contains a BEC in it, usually by the label. It often says something like BEC 2 amps 5 volts. That's what this one's rated for. It means it supplies 5 volts to my receiver and allows 2 amps worth of current to go through it. Now, some ESCs, you will find, the larger ones specifically, have no BEC with them. That means you have to supply the BEC yourself. You can buy them separately. They're just another component to wire in the circuit. Reasons being is you may want to swap out at higher amp speed controls, you may want to swap out what type of BEC you're using, because there are two main types of BECs. They're both voltage regulators, it's just how they do it. One type of BEC is a linear voltage regulator. That regulates voltage through the dissipation of heat, which means it's going to get hot. If I had an 80 amp speed control with a linear voltage regulator embedded in it, chances are it's going to get very hot and possibly damage the speed control part because it has to work extra hard to take 80 volts worth of power and regulate that down to the 5 of your receiver. Your smaller speed controls, it's not that much of an issue, that heat dissipation. So you don't really need to have an ESC without a BEC there. It can be embedded with inside it, and then you're fine. Another type of BEC is a switching voltage regulator. That just switches through on and off of your power. Either way, the bottom point is that some ESCs have a BEC embedded inside them, some don't. So you just have to know, you just have to look at the label and see whether or not your BEC is there or if you have to supply your own. Like I said, most of your smaller ESCs have the BEC in there, and that's what you'll take to power your receiver and servos. Choosing the right speed control from a power standpoint. In your entire RC circuit shown here, you have a constantly changing equation you must balance to make sure you don't overtax one part of your system. However, since the ESC is typically taking all the current from your battery, it needs to have the highest amp rating over any other part. You can always go higher in amperage on an ESC to be safe, but you can never go lower. But what is lower? Lower than what? Lower than the maximum amperage you'll be pulling through your circuit. This means everything that uses power, your receiver, servos, and motor. The combined amperage pull from those components must be less than your ESC's rating. So look at this example here. If you have a motor that is rated at 18 amps maximum current allowed, and say the servos and receivers will take no more than 1 amps, you could get away with the 20 amp speed control. However, I like to play it a little safe for a few reasons, and would go with the 25 amp speed control. Remember, the ESC rating can always be higher than you need, and at that point it comes down to an issue of weight. Higher amp ESCs weigh more. One thing I generally keep in mind is that if you crash and your throttle is up, this can cause an amp spike through your circuit. So a 25 amp ESC would have a chance to handle that spike better than a 20 amp ESC. We also keep that in mind with our plane-to-plane combat, where your prop is a weapon. That can also cause an amp spike. Of course, we need to make sure the battery can safely discharge that many amps, and in our case, it can. 20 amps continuous, 24 amps burst, so we'll be safe here. That's why the general rule of thumb is your ESC amp rating must at least be greater than your safe battery discharge, which in turn must be greater than the load on the circuit, receiver, servos, and motor combined. Now you can see why a watt meter is so nice to have when you're calibrating your circuit. You can rev up the motor, move all the servos, and use the watt meter to see exactly how many amps you're really pulling through your circuit. If you change any parts of this circuit out, you'll need to make sure the rest of the circuit can handle it. Say I put a bigger motor in that can pull 30 amps. Well, now I need to upgrade my ESC and battery to handle the extra load. Always keep that in mind. Change one part of the equation, and you need to balance it out. Electronic speed control programming. ESCs often have different programming options that allow you to customize how they work. There are simply way too many brands of ESCs out there to cover in this article, but we'll look at a few of the most common methods and options for programming an ESC. They could typically be programmed through 3 different methods: USB programming kits, which hook into your computer, programming cards, which hook into your ESC and a battery, or throttle stick programming. Using your ESC and transmitter, you can program your ESC through a set of audible beeps. Now keep in mind that different brands of ESCs can't all be programmed the same way. You'll need to read your ESC's instructions and learn how to program it and which programming methods it supports. Each ESC maker is different. Clearly, programming an ESC is going to be another video and topic, and you can see that some options to program them with are more tedious and error-prone than others. But now that we've looked at how an ESC could be programmed, let's look at some of the most common programming options. The list of options is not necessarily related to a specific ESC. This is just a sample of some options your ESC may or may not support. Often ESCs can auto-detect or have default settings for these options. Battery types, often defaulting to LiPo, but can be changed to support NIM or NiCad batteries. Low voltage cutoff, extremely useful for LiPo batteries. You can program your ESC to tell it when to cut off power to your motor and whether or not it does this in a soft or hard fashion. Low voltage cutoff level. This protects your LiPos by telling your ESC to power off your motor if your LiPo pack goes down to, say, 3 volts per cell or 3.2 volts per cell. Brake setting, enable or disable. This means if you reduce your throttle, does the ESC tell your motor to spin freely until it stops, or to stop turning immediately? Startup mode, soft or hard. Hard is often used for airplanes, soft is used for helicopters. All comes down to what you're flying, but this deals with how fast the ESC lets your motor accelerate. Timing, low, medium, or high. An advanced setting for brushless motors related to the signals sent from the ESC to your motor. You can generally use the default, but you may need to research your motor and ESC preferences together to know how they should fit. Throttle range, auto or fixed. This often depends heavily on the model, helicopter or airplane, and deals with how the transmitter throttle stick corresponds to the output of your ESC to your motor. That's a taste of your most common ESC programming options, which we may cover someday in detail. In the end, though, we've covered the high-level basics, but most importantly, the power considerations in choosing the right ESC for the job. All right, a quick recap. ESCs allow you to bridge the gap between your motor, battery, and your receiver. It sends signals to your motor to tell it to turn based on the throttle channel that hooks into your receiver. It takes the power through your battery. You've got to keep brush to brushed, brushless to brushless. You've got to watch whether or not your ESC has a BEC inside of it. If it doesn't, you got to buy a BEC separately and wire it in. That BEC keeps the voltage down for your receiver based on the power input you've got. Remember your power ratings. Take the entire load on your circuit, the amperage total of your motors, servo, and receiver combined. Make sure that your battery can discharge that amount safely, and then you make sure your ESC is rated above the total load that you'll be pulling through your circuit. I'm Eric R. Christoph of HoverAndSmile. Hopefully this brief, high-level introduction to ESCs has given you a little more food for thought about some of the options you have to program them with, but more importantly, the power considerations when designing your RC circuit. Thanks for watching.